Hello मेरे प्यारे बच्चों, welcome back. I know, exams are just around the corner and the tension is building up, right? Don't you worry at all. Today, we're going to tackle a super important topic from computer science, searching. And trust me, we're going to make it so simple you'll remember it forever.
Just think about it for a second. You grab your phone, you need to call Ravi, you type just the letter R, and bam, he's right there on top of the list. It happens in less than a second. Your phone doesn't get stuck, it doesn't take 5 minutes to think. How does it do that? Is it some kind of magic? Well, not exactly. It's actually really clever computer science, and today, you and we're going to uncover that very secret. So what is this searching all about? Honestly, it's super simple. Imagine you have a huge box of chocolates, and you're looking for that one special caramel one. That caramel chocolate is what we call the key. The whole process of looking for it is searching. And at the end, the answer is either, yay, I found it, it's right here, or, aw, it's not in the box. That's all it is. All right, to make this super fun, let's pretend we're playing a video game, okay? It's time for level 1. This is the starting level, the most basic way to search. It's called the linear search. Are you ready, player 1? Let's do this. Now, linear search is, well, it's exactly what its name suggests. It's very simple, very straightforward. It just goes to the very start of the list and checks the first item. Is this what we're looking for? No? Okay, let's check the second one. Is this it? No? And it just keeps going, one by one, in a straight line, right until the end. No jumping around, no clever tricks, just patient, hard work. That's why it's also called a sequential search, because it just follows the sequence. Oh my God, you know what this reminds me of? That moment of panic when the exam results are put up on the college notice board, right? It's just a huge, messy list of roll numbers all jumbled up. So what do? You have no choice. You start from the very top, check the first roll number. Nope, not mine. Then the next one, still not mine. You have to scan every single entry until finally you find your number. That whole stressful experience, that, my dear Bachchan, is you doing a linear search in real life. Okay, let's see exactly how a computer does this. Look at this list. We're on a mission to find the number 17. The computer is very simple-minded. It starts at the very beginning, at index 0. It asks, is A equal to 17? Nope. Okay, on to the next one. Index 1. Is minus 4 equal to 17? Nope. Move on to index 2. Is 7 equal to 17? Still no. Let's try index 3. Is 17 equal to 17? Yes, we got it. The search is over. The computer says, found it. It's at index 3. See? It's a very simple step-by-step process. Now, this is all fine and dandy for a tiny list of 7 numbers. But what if the list had, say, 10 lakh items? Imagine your phone contact list has 10 lakh people. If your phone used this one-by-one method, you'd be waiting and waiting for minutes just to find one person's number. Can you imagine how annoying that would be? So this brings up a very important question. Isn't there a smarter, faster way to do this for really, really big lists? Well, of course there is. And that brings us to level 2 of our game. This is the smart upgrade. It's called binary search. And Bachchan, this one is not just faster, it's smarter. It's like you stop walking everywhere and suddenly you have a ticket for the super fast metro train. But wait, this metro has one very, very important rule before you can get on. I call it the golden rule. Please, Bachchan, take out your pens, highlight this in your notebook, put 5 stars next to it. For binary search to work, the list must, and I mean must, be sorted. It has to be in order, like from smallest to biggest. If the list is all jumbled up like our notice board, this method just won't work at all. This is a favorite question in exams. They love to ask this. And here's the perfect way to understand it. Think about a physical dictionary. If you want to find the words, say, Python, do you start at page 1 with the A words? No way, right? That would be silly. You instinctively open it somewhere in the middle. You see you've landed on the M words. Now you know P comes after M, so you can completely ignore the entire first half of the dictionary. Just like that, you've thrown away thousands of pages without even looking at them. That is the magic of binary search. So how does it work step by step? It's simple. 1. Find the middle element of your sorted list. 2. Compare. Is the middle element the one you're looking for? If yes, great, your job is done. 3. If the number you're looking for is smaller than the middle one, you know you only need to look in the first half. So you can just chop, get rid of the entire second half. And 4, if your number is larger, you do the opposite. You get rid of the first half. Then you just repeat the whole thing on the smaller piece that's left over. Easy. Okay, let's try it out. We're looking for the number 2 in this nice sorted list. First, we find the middle. The middle element is 17. Now, we ask, is 2 smaller or larger than 17? It's smaller, of course, so we can take the entire second half of the list from 17 onwards and poof, it's gone. We don't need it. Now we look at the small list that's left. What's the middle of that? It's 7. Is 2 smaller than 7? Yes, it is. So we do it again, slash. We get rid of the second part of this little list. Do you see what's happening? With every single guess, we are cutting the amount we have to search in half. That's its superpower. So binary search is awesome, right? It's so much better than the slow, plodding linear search. But computer scientists are never satisfied. They're always looking for more speed. So they started thinking, is there a way to be even faster? Can we find an item not just fast, but instantly, like in one single go? What do you think? Get ready, because it's time for the final level. The boss level, level 3, hashing. And this is not just another upgrade. Hashing is like finding a secret, magical shortcut in the game that takes you straight to the treasure. It is the secret ingredient that makes so many apps on your phone feel lightning fast. With hashing, you can forget about checking things one by one. You can even forget about cutting the list in half. Hashing is totally different. It uses a clever little formula, we call it a hash function, that takes your item, does a quick calculation, and directly tells you the exact spot, the exact index, where it's located. There's no searching at all. It's like having a GPS that instantly gives you the final destination coordinates. Here's a great way to think about it. Imagine you're in charge of a massive warehouse, like for Flipkart or Amazon. A new item comes in. Instead of wandering around for hours looking for an empty shelf, you have a magic formula. You put the item's name into the formula, and it instantly spits out a number, like shelf 247. So you go straight to shelf 247 and put it there. Later, when a customer wants that item, you don't search the whole warehouse. You just use the same magic formula again. It tells you shelf 247, and you go right there. That magic formula, that is your hash function. So what does one of these magic formulas look like? Well, a really common and simple one is called the remainder method. Let's say we have a storage space with 10 slots numbered 0 to 9, and we get a number we need to store, say 77. The formula is divide the number by 10 and find the remainder. So what's 77 divided by 10? The remainder is 7. Perfect. So we put the number 77 directly into slot number 7. Let's try another one, 93. What's the remainder when you divide 93 by 10? It's 3. So 93 goes straight into slot 3. Later, if you need to find 77, you don't search. You just do the calculation again, get 7, and look in slot 7. Boom! One step. Okay, but there is one small catch. Hashing is not a perfect superhero. What happens if we get the number 16? The remainder is 6, so it goes in slot 6. But then we get the number 26. What's its remainder? Also 6. Uh-oh. We have 2 different numbers that want to go into the very same spot. This problem, this little traffic jam, has a special name. It's called a collision. Now, there are clever ways to solve this, but for your exam, you just need to know what a collision is. Okay, so we've met our 3 contenders in the ring: the hardworking linear search, the smart binary search, and the magical hashing. The big question is, which one is the best? Which one should you use? Well, it depends. So let's have a final showdown, a quick comparison that will make everything super clear for your revision. Okay, Bachones, eyes on the screen. This single table is basically your entire chapter summary. Let's break it down. First, speed. Who's the fastest? No competition. It's hashing. It's practically instant. Binary search is the speedy runner-up. It's very fast. And poor old linear search, well, it's the slowest. Now the big exam question. Does the list need to be sorted? For linear search and hashing, you don't care. The list can be a mess. But for binary search, it's the golden rule. It is a must. So the final verdict? Use linear search for small, jumbled-up lists. Use binary search when you have a large, sorted list. And use hashing when you need pure, unbeatable speed. All right, my champions. Time to put on your exam mode thinking caps. Let's practice with a question that you are very, very likely to see in your paper. Let's solve it together right now. Okay, read the question carefully. It's asking 2 things. Part 1, Why is binary search more efficient? That's just a fancy word for better and faster than linear search. And part 2, what is its most important condition? Its prerequisite. Just think back to our analogies. Think about the messy notice board versus the organized dictionary.
And here is your full marks answer. You write it in points. Point 1. Binary search is more efficient because it follows a divide and conquer approach. Remember that phrase. It means it cuts the search area in half with every check, which leads to far fewer comparisons, especially in large lists. Point 2. The killer point. Its main prerequisite, its golden rule, is that the list must be sorted before you can use it. You write these 2 points, use these keywords, and I guarantee you will get full marks.
And there you have it, the entire topic of searching made super easy. Just remember our stories, the slow notice board for linear, the clever dictionary for binary, and the magical formula machine for hashing. If you remember the stories, you'll remember the concepts. You are all so bright, and you've absolutely got this. Revise these points, stay confident, and you will rock your exams. All the very, very best from me. Bye-bye.